All right, superstars, welcome to lesson 7.4b. It says repeating decimals. And we know chapter 7's going to add a lot of information, but it's all interconnected. And if you remember, repeating decimals, those are rational numbers. So we're going to go ahead and convert our rational numbers to our standard fractions that we spent a lot of time on in 7th grade and early in 8th grade. The 7th graders right now are learning how to convert fractions to decimals and to percents, which is what you did last year. So as it states, our objective there, we're going to go ahead and show you a little tips and tricks. Some of our superstar students might be able to recognize a certain pattern for some of the problems, and that might be helpful for you if you can actually do that for your next assessment, which again is going to be your Chapter 7 test, which according to our date is going to occur on January 27th. So a Friday, January 27th. So as we continue on, remember rational numbers, we know fractions. That is key. So we asked you to memorize some fractions in 7th grade. 1/3, well, you knew the decimal, 0.333, repeating 1/3. So some of them are really easy and going to match up with previous knowledge, but some we're going to show you how to do a little bit more difficult. So follow the format. Those terminating decimals, remember, those are the easiest ones from 7th grade. So we're going to test your knowledge really quick to see if you remember how to change a terminating decimal into a nice, beautiful fraction. One of my favorite ones is 25 cents. We know 25 cents is 0.25, and some of you are automatically thinking that is 1/4 or 1/4. One of the things we do have difficulty with some students doing continually, still in 8th grade though, is of course forgetting to reduce or simplify your fraction. So don't be that student. So for example, if you say that 0.8 and you know that that is the 10th place, and you simply write it as 8/10, you would be incorrect. In fact, we had a problem just like that on our assignment today as I am recording this. You had to take the square root of a fraction, and it was 10/2, and some students left it as 10/2. You need to go ahead and simplify it, reduce it to be a 5. So for this one, we know they can both be divided by 2, so we have a simple 4/5, 4/5. The repeating decimals, as I already shared, some of them, like 0.33 repeating, we can still write it as a fraction. So for example, a 0.6 repeating, some of you might know that one automatically. If 0.33 repeating is 1/3, 0.666, all of those things repeating would be 2/3. But we're going to show you how to get that in case you did not have some of them memorized. For example, there's a lot of repeating decimals that we don't have memorized. So if you follow our format, things will be awesome for you. All right, some 7th grade problems. Go ahead and write that one as a quick fraction, please. Figure out what place value you have, make a simple fraction, and then of course ask yourself, can I reduce? Can I simplify? Can I divide my numerator and denominator by any like term? You're like, this one's too easy, Miss Maria. 7/10. 7/10 cannot reduce, simplify, make it smaller, so we have our magical number, 7/10. Let's go ahead and try another quick one. Be careful. Figure out what place value you have, 0.64. I think this one you might have to reduce. My superstars are saying, yeah, you do. And if you didn't know, we have another awesome set of students joining us. I believe Miss Fung's Math 8 class is going to be enjoying this as well. So we've got, no, sorry, Miss Deng's class for this one. There you go. Shout out to Miss Deng's class. So we've got 64/100. Superstars are not going to stop there, though. If you divide by 2, you might have to do that more than once. Some of you might know, looking at it, if I divide by 4, kind of bringing in those square roots and cube root knowledge. And then, of course, divide by 4 there. Giving you a moment to write your answer. Be confident. 16/25. So again, those ones are too basic, but the concept of knowing what place value, that's the key piece. Remember, the first one after the decimal is the tenths place, then the hundreds place, then the thousands place, and so on. because we're actually going to use that information to help us out in just a moment with our repeating decimals. All right, go ahead and try it one more with this negative 3.215. With the integer part in the front, it does tell you you're probably going to have an improper fraction. What's the place value? What's the fraction? So we have a mixed number first, and then we might practice changing it into an improper fraction. So your place value there, you know, the 5, that is going to be your thousandths place. So we're going to put a 1,000 for our denominator. And then we want to reduce it. Now, some students may say, I'm going to try dividing by 5. Some students might say, I'm going to try and divide by 25. You guys figure out what's the best number to divide by. Some of you might be able to do it in your head. Others, you might have to go off to the side and do a little bit of division to check, but I think it's 5. So if we reduce that, we're going to have a negative 3, which is our whole number or integer part there. And then we have a 43 over, what'd you guys say? 200. Now remember, if we wanted you to change it into an improper fraction, like we've practiced before, you're going to take your denominator, multiply it by your whole number. Don't worry about the negative sign yet. We already know it's a negative answer. And then we're going to go ahead and add our numerators. So 200 times 3 is 600. Add the 43. So it'll be 643 over 200 with the negative sign. There we are. I personally like putting, when I'm handwriting everything, personally like putting that negative sign at the numerator. Some people like putting it in the front as it appears on the screen. Just make sure again that your negative sign and your fraction line do not combine. So it looks like a really long fraction line or a positive answer. All right, now let's get to our important part. This is what the majority of your your quiz is about. There are some problems on the back where you're going to work with your standard fractions and decimals, practicing some of your 7th grade skills, kind of going with the ones we just did. But we want to focus on the 8th grade form, which is right here, write as a fraction. So our first thought is let's go ahead and change it into an equation, because if we have some good equation knowledge, meaning solving equations all the way back from 7th grade, maybe even earlier, then you're definitely going to be prepared for trying to find this fraction. So we're going to go ahead and just basically say that x is 0.3 repeating. So we're going to assign an x to the front to help us determine what we can do to get a repeating decimal into a fraction. The first thing you should be thinking about is what's the place value? Well, the repeating bar, remember, if we had more digits, it'd be a different place value, but the repeating bar is currently located at the 10th place. So we're going to ask you to imagine having a 1x turn into a 10x. And the way we do that is we essentially multiply by 10. So 1 times 10 is 10, but what is 0.3 repeating multiplied by 10? Well, maybe you remember the trick from 7th grade and earlier is really you just got to move your decimal one place. So the 1 now becomes a 10, and the 0.3 repeating, when I move it, it now becomes, what do you think? Yeah, 3.3 repeating. Because remember, 0.3 repeating really means 0 point and then a bunch of 3's. So if I move my decimal one place, then I have it as a nice 3.3 repeating. It's still repeating a bunch of 3's. So we have a 10x now, and we have a 1x. So if I go ahead and structure my equation like this, kind of similar to what we did in chapter 5 with the elimination method, then, oh, look at the word right there, I can eliminate my repeating decimals. 10x subtract 1x, that's just a simple 9x. 3 subtract the 0 is just a simple 3, right? Especially since the repeating decimals can now cross out. So if you have a second color, go ahead and do that real quick. Cross off very lightly those repeating decimals. which really just gives me a nice 3. Now remember, some of you already knew that 0.3 repeating was the fraction of 1/3, so we're really just training you how to do this format. If I divide both sides by 9, reducing my fraction, I do get a nice 1/3. Oh yeah. And in Chapter 8, we're going to be dealing with so many calculators, but right now you're not just going to type in 1 divided by 3 and see a bunch of decimals. The advanced calculators can actually do it backwards for you. So again, we're teaching you some great strategies, but it's really just solving equations, trying to solve some advanced equations, changing a repeating decimal into a fraction. All right, let's try a few more. Then we'll try some homework problems and then do one more problem on the notes. And then you'll try and finish up your assignment as much as you can before class is over. All right, so same pattern. If you notice, it is currently the tenths place. So let's go ahead and write it as x is going to be equal to 0.7 repeating. But remember, we really don't want a 1x, we want a 10x to help us solve our equation, which allows us to find our fraction. And the reason I know I'm going to do a 10x is because the place value that is being repeated is the tenths place. So let's go ahead and move it 1 space to move it 1 space. Really, it's just multiplying by 10. So 10x is going to be equal to, try and see what you remember what we did on the previous problem. You can look at that. It became a 3.3 repeating, so now we have a 7.7 repeating. We're going to line it up to have our elimination occur. 10x subtract 1x is another nice 9x. The repeating decimal part will eliminate. So 9x is 7. So it means if I divide, x is going to be 7/9. That is my fraction form of my nice repeating decimal. Now, the format doesn't matter or can be used if you have a repeating tenths place, hundredths place, thousandths place, as many as they are given to us. So on our next one, if you notice, we have a repeating 2 and 4. So we're going to essentially say, okay, that is going to be the hundredths place because it's 2 spaces after the decimal. So keep that in mind. The previous one, we were repeating the tenths place. This one, we're repeating the tenths place and hundredths place. So instead of a 10x, what do you think we need to use? Thank you for your participation. We're going to actually move it twice because we're going to deal with a 100x. So it's kind of like multiplying it by 100 when I move it twice. So off to the side, go ahead and write 100x is equal to, and if I move it 2 places, what do I really have? Remember, it's just a bunch of 2 4s repeating, so I now have it as 1, 2, 4, point, and then the 2, 4 is still repeating. When I line it up, and here's the key part from when we get to the harder problems. When I line it up, I have to have my repeating decimals line up. So if you notice, I have a 2, 4 and a 2, 4 repeating, and they both line up correctly. So be very careful there. If I subtract, I get a nice 99x. And then, once again, my repeating decimals are going to eliminate. We cross them off really lightly. And then it's basic subtraction. Please be very careful at the very end, though, and ask yourself, can I reduce 123? Can that reduce to become a smaller number with the 99? And we actually have been practicing our divisibility rules in class. 123, can that be divided by a 3? Let's see, if I added them up, 1 plus 2, adding the digits, I should say. 1 plus 2 is 3, plus another 3 is 6. 6 can be divided by 3, which means 123 can be divided by 3. So if I do that, what do I get, though? Some of you know it. If you really don't know, you can go off to the side, to the margin, and do your division. But to save time, just go ahead and write down a 41 over 33. Now remember, this is a fraction. We want the fraction. We don't necessarily want the mixed number. Our goal today is to change a repeating decimal into a fraction. All right. So our awesome substitutes are going to pause the video. You're going to pass out the worksheets. And then as soon as every student has a worksheet, you're going to restart the video so that I can help with a few problems. We're going to go ahead and do 2 together on the assignment. Then we'll come back to the official notes, so don't put your notes away, please, to do one of the more advanced problems. And then we'll look at an advanced problem on the assignment as well. And then your remaining time, you will work on your assignment. All right, pause it now, please. All right, welcome back. Let me see if I can get this ready. Let me see. Yeah, my good old Cami is ready. All right, let's go ahead and try number 2. We're going to do number 2, which is a nice basic one, like our first example of the 0.3 repeating. If you remember, we're going to go ahead and assign an x to be a 0.5 repeating. But essentially, we said it was a 1x. And since this is the tens place, we're going to go ahead and move our decimal 1 place on both sides, which is really like we're multiplying by 10. So over here, I'm going to write it as 10x is equal to, and then the repeating part, remember, is now going to be 5.5 repeating. The original one, the 1x, is going to be brought below. So we're going to write 1x is equal to, and this is the 0.5 repeating. But remember, we're going to subtract. We're going to find the difference between the two. And the reason we would subtract instead of add is so that those repeating decimals can eliminate. So let's see here. Lightly cross them off, which means I now have a 9x is equal to a 5. Divide both sides by 9. So that means x is equal to 5 over 9. Excellent, excellent. All right, so you've got another basic one like that on number 1 and number 3. 4 is the double one. Let's do number 5. Number 5 is just like one of the the note problems that we just did. We're going to start off with the same process. We're going to say x is equal to 0.21, and notice the 21 is repeating. We're going to put a little 1 here. And since this is the tens place and hundredths place repeating, we're going to move our decimal twice. 1, 2, 1, 2. Which really tells me instead of a 1x, instead of a 10x, I should be using 100x. And if I move it 2 places, that would really be a 21.21 because the 21s just keep repeating. All right, if I line up my 1x, you're going to ask yourself, lining up your decimals, does my repeating decimals line up? Yeah, if you notice the 21, 21 repeating. So let's go ahead and subtract. 100x subtract 1x is 99x. Sometimes it becomes a 90x. That's one of the more advanced ones we'll look at soon. But on this one, we got a 99x. Go ahead and eliminate that. We have a 21. Ooh, almost there. Divide by 99. And then just like on the notes, we ask ourselves, can we reduce it? Like our previous one, 5 over 9, pretty standard. You can't reduce it. But this one, I think we can. 2 and 1, I add those up, I get a 3. So let's go ahead and divide by 3. So we have a 7 over 33 for our fraction from our repeating decimal. Excellent. You're going to get some more homework help in just a moment. Let's go ahead and flip back to our notes. So just put your worksheet off to the side, and we're going to look at one of the more advanced problems. Now, the reason we call it one of the more advanced problems is because if you appear to see this problem, the 8 is not repeating. Uh-oh. If the 8 is not repeating, what are we really going to do? Now, it just depends on what you have. So, for example, maybe it was only the 3 repeating, but this time we have the 2 and the 3 repeating. All right, so we're going to start off the same way. We're going to say x is equal to. So let's see, x is equal to, and then we just say 0.8, and then the 23 is repeating. All right, now we count up our place values again. We've got the tenths, hundredths. Ooh, the 3 is at the thousandths. So our 1x, let's see, does it fit? Move it once, twice, thrice. Fancy way to say it. Same thing over here, once, twice, thrice. So instead of a 1x, instead of a 10x, instead of a 100x, we need a 1000x. And if we do that correctly, we're going to go ahead and have this. Because again, if we move it 3 times, the 23 is still repeating after the decimal now. All right, beautiful. So now the question is, if I have a 1000x, do I need to keep it as a 1x? Do I need a 10x? Or do I need a 100x? Because remember, the whole point is to have those repeating decimal parts line up so that they, when we subtract, they would eliminate. So let's go ahead and see here. If I move it 1 space to give me a 10x, oh yeah, there we go. A 10x is going to give me an 8.23 repeating. Notice how I lined up the actual decimal, and then I lined up my repeating 23s. Very nice. If I had used a 100x, it wouldn't have lined up well. If I used a 1x, it would not have lined up well. The 10x was the magic number there. All right, so when we subtract, we get 990x, so not 999. So for some of you who are trying to come up with that pattern or that trick, it doesn't work absolutely every single time. And if I subtract, I get 815. Divide both sides by a 99 with a 0. And then we're going to go ahead and reduce it. If we divide by 5, everything's going to be good. Again, you can go off to the side and do that, but to save time, let's just go ahead and say x is equal to 163 divided by 198. So nice fraction. Again, something that you would not be able to find in your head, which is why we're asking you to try this pattern with us. All right, so let's try one more problem together to help you out, just like what you saw. Let's go ahead and do number 8. So I'm going to give you a moment to see if you can set it up, just like I helped you on the last notes problem. This will be the last homework problem I'm going to help you on, and then you'll have some time for your own, or maybe your partner help, to try and complete it. All right, I'm going to give you about 30 more seconds to set it up. Ten, 9, 8. All right, let's see. You should have written x is equal to 0.412, where the 1, 2 is repeating. Put a little 1 there. That's our 1x. The 2 is at that thousandths place, which tells me move it. Come on. Silly Microsoft. Move it 1, 2, 3, because we got to move it 1, 2, 3. So just like our notes, we're going to say 1000x is equal to, now if I move it 3 times, my decimal moves after the 2. So that would be 412 point. But remember, the pattern repeating, it would be 1, 2, 1, 2, 1, 2. So I'm going to go ahead and put 1, 2 repeating still. Now, if I use 1x, meaning I line up my 1x, I would not be having the 1, 2 lined up perfectly. But if I move it one place, which would be represented as a 10x, then I would have one placement moving, which would be a 4.12 repeating. Sometimes you might have to move it twice, but on this one, we just move it once. So let's go ahead and subtract. Equal signs line up. We've got 990x is equal to, again, the repeated parts cross out. So that means we have a 408, and we're going to divide both sides by 990. All right, we definitely know it can divide by 2 because it's an even number. So let's see, that would be a 204. And then if you didn't know to divide in your head, again, my suggestion was to go off to the side. Now it should be pretty close to 500, right? Because it's pretty close to 1,000. Ooh, scary. Some of you know just looking at it. Others, you might have to go off to the side and divide. So again, 2 times 4 is 8, which is really close to 9. 2 times 9 is 18, which is really close to 19. And 2 times 5 is 10. So that's 495. All right, double checking so I don't make a fool of myself on there. Number 8. Oh, man, we continue on again. Come on, Mr. Murillo. Let's see. What are we going to divide by? What are we going to? Did I do it wrong? I really hope not. Don't think so. But again, based off of time, you're going to go ahead and try and reduce this a little bit more. Maybe the answer key's wrong because some of the students make mistakes, things like that. I'm going to say, based off my quick understanding, I think I'm correct. But again, if I'm incorrect, go ahead and free to point me out. But again, let's double check. We got our 990. Subtract, get 408, right? Fun times, fun times. All right, we're going to go ahead and pause there. And on a strong note, yay, Mr. Murillo. Let's go ahead and see what you can do on your own, please. All right, be an awesome student. And we'll take any questions the next day.